Hi everyone. In this session I am going to be discuss about the traveling salesperson problem using branch and bound. So I hope you are good at traveling salesperson problem statement, but once again I want to discuss that problem statement. We have a graph, nothing but some vertices. Each vertex maybe you consider as a city. Our aim is from you must be choose one city or one vertex is your starting vertex. From that you must be visit all other vertices or cities, and from the last city to the starting city you must be reach with minimum cost. Here edges having cost, you must be spend with a minimum cost. So this problem we called as optimization problem. So because our solution always demands the smallest number, smallest cost. So when it is the smallest cost, this minimization problem is also called, this optimization problem is also called minimization problem. So minimization directly solved by using branch and bound. Yes, we are going to be use the branch and bound. Here also I am going to be use the least cost approach with the help of a reduced cost matrix. With the help of reduced cost matrix. All the branch and bound problems we consider as the NP hard problems. So this is also NP hard, and its time also exponential. We are going to be set the bound with the help of least cost approach and also with the help of cost reduction matrix. So for example, I hope you good at the problem statement. Now let us consider this is our cost matrix. Nothing but I have the 5 vertices. So these are the paths 1 to 2. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Nothing but 1 to 2 is 20, 1 to 3 is 30, 1 to 4 is 40, 1 to 5 is 11, and so on. First step is what is the cost initial adjacent cost matrix we have. For that we are going to be find the minimum row value. How many rows we have? 5 rows. Each row we are going to be find the minimum value. Here what is the minimum value? 10. Here what is the minimum value? 2. Here what is the minimum value? 2. Here what is the minimum value? 3. Here what is the minimum value? 4. Once you find those minimum values from the given cost matrix, you must be subtract that value in that row. So that means first row we have these values. From these values we are going to be subtract 10. So one to 1, infinite. Infinity minus 10, infinite only. So 20 minus 10, 10. 30 minus 10, 20. 10 minus 10, 0. 11 minus 10, 1. For the second row, what is the second minimum second row minimum value? 2. So 15 minus 2, 13. Infinity. 16 minus 2, 14. 4 minus 2, 2. 2 minus 2, 0. For the third row, what is the minimum value? 2. 3 minus 2, 1. 5 minus 2, 3. 2 minus 2, 0. And 4 minus 2, 2. For fourth row, what is the minimum value? 3. 19 minus 3, 16. 6 minus 3, 3. 18 minus 3, 15. 3 minus 3, 0. And for the last one, what is the minimum? 4. 16 minus 4, 12. 4 minus 4, 0. 7 minus 4, 3. 16 minus 4, once again 12, and infinite. So this is the matrix we are getting after row reduced or the row reduction matrix. Now, what is the total row sum reduced? Nothing but the smallest of each and every row. What is this sum? 10 plus 12, 14, 17, 21. This is the row sum. After this, you must be find the column. So we have the rows now. For each column, we are going to be find the minimum value. So in this column, what is the minimum value? I am going to be right here 1. For the second column, 0. For third column, 3. For fourth column, 0. Fifth column, 0. Now, for each and every column, you must be subtract the corresponding column smallest number. So infinity, 12, 0, 15 and 11. And here 0, nothing but the same, 10, infinity, 3, 3, 0, 20, 14, infinity, 15, sorry, we have 3 na? Yes. So you must be subtract 3 from each and every one. So 17, 11, infinity, 12, 0. Fourth and fifth are small zeros, so you can write as that is 0 to 0, infinity, 12, 1, 0, 2, 0, infinite. So now find the column sum of smallest numbers. 1 plus 3, 4. So this is after column reduction cost matrix. After column reduction, the cost matrix is look like. So after performing the row reduction and column reduction, what is the cost matrix we have? That is our node 1. And for the node 1, what is the cost it having? The row reduction sum plus column reduction sum. What is the row reduction sum? 21. What is the column reduction sum? 4. 21 plus 4, 25. So that is our first node cost. From that, we are going to be choose all other possibilities. Nothing but like this is our cost matrix. Check it once. So what we have getting? So this is our reduced cost matrix. What is the cost? Here we are getting 24. So we are going to be assigned with our node. What is that node cost? 25. Now we are going to be check. I am going to be next visit either second node or third node or fourth node or fifth node. So I am going to be give the numbering also like this way. My next may be the 2 or 3 or 4 or 5. So this is our solution for that. Now I am going to be consider here what is the node I am going to be consider here 2. So that means from this after row and column reduction matrix, what I have, what is this path? 1, 2. Nothing but the corresponding rows and corresponding column 1, 2. What is that meaning? 1 is a row and 2 is the column. So first row from this reduction cost matrix, first row and second column I not considering in the sense set as infinite. The rest are the same. Along with what is our path? 1 to 2. 1 to 2. So nothing but in my cost matrix 1 to 2 also, what is a 1 to 2 cost? 12. I consider 12 plus this cost reduction. What is that cost reduction? 25 plus. Now I am going to be get what is the reduction at this node. So that's why I consider the 25, the previous cost reduction, and path cost of 1 to 2. So that is 1 to 2. So when I consider 1 to 2, it also must be set as infinite, because I consider that also. Now I am going to be considering for the reduction. Reduction is nothing but you must do the reduction for the row as well as the column. So for this one, I am going to be check for the row by row. What is the smallest number here? Nothing. Here 0, here 0, here 0. Observe 0, 0, 0, 0. There is no reduction. But what about the column? Check it. 0, 0, 0, 0. So then what is the after row reduction and column reduction cost? 0. What is the total cost at this node? 25 plus 12, 37. So if you do the proper calculations, definitely. So what is this value? So 12. Okay. So we will write after nothing but the normal basic calculations. This one, what is the value we are getting? You can assign it. So then go for the next. What is that? 1, 2, 3. So when you are going to be consider this 1, 2, 3 from this cost matrix, the same you can apply 1 and 3, nothing but 1 is the row, 3 is the column. So this one and this one. And what is the cost as of now? 25 plus. What is the cost of 1, 2, 3? 17. 1, 3, 17. Okay, and you will find the same for that, nothing but you must be apply the same row reduction as well as the column reduction. So when you apply, then what is the value we have here? 2, 0 minimum, 0 minimum, 0 minimum. What about the column? So 1, 2, 3. So that means 3 to 1 also not possible. So 1, 2, 3 we set the infinite, and 3 to 1. 3 to 1 we are also going to be set this is our infinite. So when 1 to 3 is infinite and 3 to 1 infinite, row 1 infinite, 3 column infinite. Now find what is the minimum here? 0. What is the minimum here? 0. What is the minimum? 0, because it is an infinite. And what about the minimum? 0. So nothing but row reduction is 0. For this one I am writing 0 plus. What about the column reduction? Check it. 11 is the minimum. Here 0, here 0, here 0. Nothing but the 11. So you must be subtract only, you must be update this one only. 11, nothing but 12 minus 11, 1. 15 minus 11, 4. 11 minus 11, 0. is this one. The rest same. So then what is our column reduction? 11 plus 0 plus 0 plus 0, nothing but the 11. What is the total value? 11 plus here, that we are going to add 25 plus 17 plus 11. What is the total value it having? 25 plus 17, 42 plus 11, 53. So we are getting here the cost as 53, like this one. In the same way, go with the 4. So for the same adjacent cost matrix, after row and column reduction of initially, now what is our path? 1 to 4. 1 to 4 is nothing but row 1, fourth column, 1 4 and 4 1. These are infinites. So now observe the same. What is the cost it having? 2 5. And what is the 1 to 4 cost? 15 plus 15. Now observe the same. Sorry, 1 to 4 is 0. Sorry, I am verifying the 4 1 0 plus. Now 4 1 also consider as infinite. Now find minimum 0 0 0 0. What is the row reduction? 0. Now check the column reduction. 0 0 0 0. Nothing is there. So then what about this node cost? 25 only. So like for the node 4, what is the cost we are getting? 24. So it does not add any row reduction or column reduction. In the same way, go with a 1 to 5. 1 to 5, as of now the cost is 25 plus. What is the cost of 1 to 5? 1 to 5. What is the 1 to 5? 1. So 1. And the row 1, fifth column, and also 5 1 becomes infinite. Now observe the rest things. What is the minimum here? 2. What is the minimum here? 0. Minimum 0. Minimum 0. So now update this one. 10 9 0, like this one. Now find the minimum for the column. Sorry, what about this row minimum? 3. Yes. So 5 3. So after updation, 12 0 9. Yes, this one. Now think about the column. 0 we have, 0 we have, 0 0. So column is nothing. 2 plus 3 5. So that we are going to add. So what is the total value? 31. So we are going to be give like this value. Now from these values, which is the minimum? We are going to be check. 35, 53, 25, 31. Which is the minimum? 25. Why we are considering the minimum? Because we are talking about the LC approach. So least cost of expanded live nodes. Which live node having the least cost, that only we are going to be expand. So when I am going to be expand this one, what is that meaning? I reach 1 to 4. Now from the 4th node I am going to be check it. Nothing but from this node I am going to be expand. From this node it may be so 1 4 visited, 1 and 4 visited, it may be the 2 or 3 or 5. So which cost matrix I am going to be consider? For the fourth node after cost reduction initially. For the fourth node after cost reduction of 1 to 4 node. What is the after cost reduction of 1 to 4 node? This one. So now I am going to be consider this matrix. For this matrix I am going to be consider 4 2 2. What is the value of 4 2 2? 4 2. So that is 13. What is the cost as of now for that node 4? 25. So 25 plus 3. 4 2 2. 3 plus I am going to be check for the 4. Nothing but 4th row, second column, and also 2 4. So what about the row minimum? 0. Here 0. So here 0. What about the column? 0 0 0. So nothing is changed. So we have the same as it is. There is no update, nothing but the 0. So what is the total value? 28. So like 28. So then go for the next node. What is this one? 4 2 3. So for the same I am going to be consider 4 2 3. So what is the value of 4 3 12? So previous 25 plus 12 plus nothing but 4th row, 3rd column, 4 3 and 3 4, 3 4, infinite. So 4th, 3rd, already this one infinite in earlier because 1 4 we visited, so that's why 1 and 4. Now which node, which path? 4 to 3. So 3 to 4 also we set as infinite, already it is infinite. Then find the minimum. So what is the minimum here? So we reach 1 to 4 and 4 to 3. So that means 3 to 4 not possible, 3 to 1 also not possible. What is the value of 3 to 1 here? 0. So that also set as infinite. Now check it. What about the minimum? 0. What about here the minimum? 2. So that means 2 we are going to be consider here 2. So after updating, this is 0 and this is 1. Yes. And this one nothing is there, this one 0. So row reduction is 0. Now check for the column reduction. What is the minimum value? 11. So after updating 0 and this is 1. So 1 0. Minimum value is 0. No need to be updated. Already we have the 1 earlier. And not possible, not possible, and not possible, 0. Yes. So 2 plus 11, 13. So 13 is going to be added. So 25 plus 12 plus 13. What is the value we are getting? 50. So 4 to 3 is 50. So in this way we are going to be find. So this value also. Now Once you generated these live nodes, 2, 3, 5, 6, 7, 8. Observe the minimum value 35, 53, 31, 28, 50, 36, which is the minimum 28. So that means 4 to 1 to 4, then 4 to 2 fix. Then the possibilities are 3 or 5. So 3 or 5 in the sense, observe 2 to 3, second row, third column. I am talking about 2 to 3. So like this one, second row, third column, and 3 to 2, 3 to 4, 3 to 1 becomes infinite. That is a basic principle. If it is 2 to 5, then if it is 5, then second row, fifth column, and 5 to 2, 5 to 4, 5 to 1 becomes infinite. After that you will find the same row reduction as well as the column reductions. So then observe. So up to this, what is the values? 35, 53, 31, 50, 36, 52, 28, which is the minimum 28. So what is that meaning? So 1 to 4, observe the path 1 to 4, 4 to 2, and 2 to 5. So which node is only pending to be visited? 3 only. So nothing but next you are going to be consider the 5 to 3. When we are going to be consider the 5 to 3, fifth row, third column, and 3 to 5, 3 to 2, 3 to 4, and 3 to 1 must be infinite. For the rest you will calculate the row reduction as well as the column reduction, that you are going to be add with 28 and also the cost of 5 to 3, edge cost of 5 to 3 plus node cost at 10, that is 28, plus is there a row reduction, is there any column reduction, you can add it. So we are going to be get finally. So what is this path? This one, 1 to 4, 4 to 2, 2 to 5, 5 to 3, and 3 to 1. So this is the minimum cost traveling salesperson to visit. So then how this is the bounding function we are going to be set with the help of LC, nothing but the list cost. So then what is the time complexity of this one? The same order of exponential 2 power n. Here not the 2 power n, if you are clearly observe the some more, but which is also exponential constant power n into maybe multiplied n square, but the higher term like must be the exponential. So once again I am repeating the general formula in the adjacent cost matrix. When you are going to be find from already you reached the node I and you want to check for the cost to reach j, that means at the node I we have one cost matrix that may be reduced cost matrix. From that reduced cost matrix you must be change ith row, jth column infinite, ith row fully infinite, jth column fully infinite. After that j to I, j to this I before, if you have some nodes, those are all nodes, j to all nodes must be set as infinite. Then only do the row reduction and column reduction. If you have any row reduction or column reduction, that must be added. What is the cost we are getting at the node I? That cost plus what is the edge cost of I to j? That is nothing but weight of I to j plus the reduced what we have, either row reduced or column reduced. If you have anything that we are going to be added, that is the cost at node j. So this is about the traveling salesperson problem by using branch and bound. The time complexity is exponential. This is also we called NP hard problem. So thank you all.